This video is an introduction to optimization problems. This is where we try to find the values of the variables that will maximize or minimize a given quantity. In a real-world situation, we might be trying to find the values that will maximize profit or minimize cost, for example. But let's start off with a few simple examples. Find two positive numbers that satisfy the given requirements. Number 4. The product is 185 and the sum is a minimum. Don't forget to define your variables. X will equal one number, Y will equal the other number. This first statement gives us a secondary equation. The product is 185. Using the variables we just defined, that means that X times Y will equal 185. The second half of the sentence tells us the quantity that we need to optimize. The sum is a minimum. For an optimization problem, you need to create a new variable for the quantity you're trying to optimize. Since it's the sum, I'm going to use the letter S. And of course, the sum will be X plus Y. So this is the quantity that we need to optimize, and specifically we need to minimize it. In other words, we need to find the values of X and Y that cause S to be the absolute minimum. Now, we've learned how to find absolute extrema in previous videos. So when we talk about optimization, just know that it will always boil down to finding either the absolute max or the absolute min of something. There are two tools that we use to find absolute extrema. Most often we use a candidates test, but occasionally we will need to use a sign chart, which is an indirect way of using the first derivative test. So when do we use which tool? We will use a candidates test when we are given a limited interval or when we have multiple critical values. In the rare case where we have an unlimited interval and only one critical value, we will use a sign chart. Either way, notice that we need to find the critical values. So our next goal is to find the critical values of S. That's where S prime is equal to 0 or where S prime is undefined. But before we go trying to find S prime, we really need to rewrite S in terms of a single variable. That's where the secondary equation comes in. If we divide both sides by X, we get Y is equal to 185 over X. Now we can take this expression and substitute it in for Y. So S is equal to X plus 185 over X, all one variable now. We want to find S prime, but that will be a little bit easier to do if we rewrite this as 185 times X to the negative 1 power. So now S prime is going to equal 1. And then a little power rule here, multiplying by negative 1, we have negative 185. Subtracting 1 from this exponent gives us X to the negative 2 power. This would be the same as 1 minus 185 over X squared. It is usually in our best interest to rewrite an expression like this where you have more than one term and a fraction. Rewrite it as a single fraction. So we can do that by multiplying this little 1 here by X squared over X squared. This gives us like denominators. So we can now write S prime as X squared minus 185 over X squared. Now it's time to find the critical values where S prime will equal 0 or where S prime will be undefined. A fraction will equal 0 when the numerator is equal to 0. So we have X squared minus 185 is equal to 0. Adding 185 to both sides gives us x squared equals 185, and taking the square root of both sides gives us x is equal to, and normally I would say plus or minus the square root of 185. However, we were told in the setup that we are dealing with two positive numbers. So let's just say x equals positive radical 185. How about where s prime is undefined? A fraction will be undefined when the denominator is equal to 0. So that means x squared would have to equal 0. But as I mentioned a moment ago, we know that x has to be a positive number. So there's no way that x squared will equal 0. So we can forget about where s prime will be undefined. There won't be any of those. So that's it for the critical values. Now it's time to decide whether we are going to use a candidates test or a sign chart to find this absolute minimum. Notice that we are not given a limited interval for the values of x and y. For example, they didn't say find numbers between 1 and 100. Now, you might notice that there is an implied lower limit because we are talking about positive numbers. So the 0 is a lower limit. It has to be something greater than 0. But there is no upper limit for x and y. You might be thinking maybe 185 is an upper limit, but there's nothing to stop one of the variables from being a decimal. So for the product to be 185, one number could be 0.00001. That would make the other number much bigger than 185. So there is no upper limit. Also notice that we have one critical value. Since we have an unlimited interval and one critical value, we need to use a sign chart instead of a candidates test to find the absolute min. So this is going to be an S prime sign chart. So I'm going to need two rows, one row for the numerator and another row for the denominator. Here's my one critical value and the lower limit of 0 because the x has to be positive. So let's decide whether these two factors are positive or negative in each interval. If I let x be any value between 0 and radical 185, this number is going to be negative. If you go to an extreme and imagine that you put in 0 right here, obviously you're going to get negative 185. But if you put in something like 1, for example, that would be negative 184. So anything in this interval is going to be negative. If you put in anything that is bigger than radical 185, you're going to be left with a positive number. When you put in a positive number and then you square it, of course you're going to get a positive number. A negative divided by a positive is a negative. A positive divided by a positive is a positive. So these are the overall signs of S prime. For a problem like this, our answer and justification will have to have three parts to it. The first derivative test tells us that S will have a relative min at x equals radical 185 because S prime changes from negative to positive. That means S went from decreasing to increasing, which is why we know it's a relative min. But what we need is an absolute min, not a relative min. To convert from relative min to absolute min, you need this second statement. Since x equals radical 185 is the only critical value, this relative min is also the absolute min. Here's why that second statement makes sense. When we found the critical values of S, we were finding where S prime was equal to 0. In other words, we found where S has a horizontal tangent line. So because S prime went from negative to positive, we know we have a relative min right here. But is it also the absolute min? Well, that depends on what happens as the graph continues. Imagine that this graph were to bend around and come back lower than this critical value. That would make this a relative min, but not the absolute min. However, if it bends back around like this, then we will have a second critical value. If we have only one critical value, that means that the graph does not bend back around and can never come back and be lower than what we have. So we know that this relative min is also the absolute min. I told you that our solution would have 3 parts to it, and so far we only have 2. So where does the third part come in? Well, we have not quite answered the question. We were supposed to find 2 positive numbers that satisfy the given requirements. So far we have found 1. We found x equals radical 185. We also need to find the value of y. So let's say at x equals radical 185, y will equal 185 over radical 185. You could leave your answer like this, but this does simplify nicely, so let's rationalize the denominator. If we multiply by radical 185 over radical 185, we get y equals 185 radical 185 over 185. A radical times a radical makes the radical go away. Of course, the 185s cancel out, and we get y equals radical 185. Okay, so x equals radical 185 and y equals radical 185. Let's add that third statement onto our final answer. The 2 numbers are radical 185 and radical 185. Number 6. The second number is the reciprocal of the first number, and the sum is a minimum. First, we define our variables. Let's let x equal the first number and let y equal the second number. The first part of the sentence gives us the secondary equation. The second number is the reciprocal of the first number. That tells us that y is equal to 1 over x. The last part of the sentence tells us the quantity that we need to optimize. The sum is a minimum. Let's make up a variable for this quantity. Let's call it s for sum. And of course, s will equal x plus y. Ultimately, we need to find the critical values of s, where s prime is equal to 0 and where s prime is undefined. But before we do that, let's rewrite this so it only has one variable in it. Y is equal to 1 over x, so s will equal x plus 1 over x. It will be easier to find s prime if we write s as x plus x to the negative 1 power. S prime will equal 1, and then the power rule, so the negative goes in the front. We subtract here and get x to the negative 2 power. Written another way, s prime will equal 1 minus 1 over x squared. When you have more than one term and a fraction is in it, it usually will make your life easier later if you rewrite this as a single fraction. We can accomplish that by multiplying this 1 by x squared over x squared. So that gives us like denominators. Now we have x squared minus 1 over x squared. This is easy to factor, so we might as well go ahead and do that. So s prime will equal x plus 1 times x minus 1 over x squared. Now it's time to find the critical values of s. That's where s prime is equal to 0 and where s prime is undefined. A fraction will equal 0 when the numerator is equal to 0. If I set this numerator equal to 0, I'm going to get x is equal to negative 1 from the first factor, and x is equal to positive 1 from the second factor. However, don't forget that we were told in the setup that we are looking for 2 positive numbers. So we can forget about x equals negative 1. Normally now we would consider where s prime is undefined, but a fraction is undefined where the denominator is equal to 0, and this denominator can't equal 0. x is a positive number, and a positive number squared will never equal 0. So we don't need to worry about that. That means x equals 1 is our only critical value. Next, we have to decide which tool we are going to use to find this absolute minimum. Are we going to use a candidates test or a sign chart? Notice once again that we are not given a limited interval. The second number is the reciprocal of the first, the sum is a minimum, but it doesn't say that x and y are between 1 and 100 or anything like that. There's no upper limit. They have to be positive numbers, so there's a lower limit, but there is no upper limit to the value of x and y. And notice that we only have one critical value. When we have an unlimited interval and one critical value, we use a sign chart to find the absolute min. In this case, the S prime sign chart. So here comes my S prime sign chart. I've made 3 rows, one for each of the 3 factors involved in S prime. Here's my one critical value, and here's my lower bound because x had to be a positive number. Now let's decide whether these factors are positive or negative in each interval. Well, x plus 1 is definitely going to be positive in every interval because we're only dealing with numbers that are greater than 0. So of course, a positive number plus 1 is going to be positive. X minus 1 is going to be negative to the left of 1. For example, if I put in 0.5 right here, 0.5 minus 1 is negative 0.5. And for values of x that are greater than 1, x minus 1 will be positive. X squared will be positive everywhere. So what about the overall sign of S prime? With one negative, the overall sign is negative. And with all positives, the overall sign is positive. The first derivative test tells us that S has a relative min at x equals 1 because S prime changes from negative to positive at x equals 1. However, we want an absolute min, not a relative min, so we're going to need another statement. Since x equals 1 is the only critical value, this relative min is also the absolute min. We're almost done, but not quite. We have found one number, x. We need to find the other number, y. The secondary equation told us that y equals 1 over x. At x equals 1, which we just found, then y will equal 1 over 1, or y is equal to 1. So that's the other number. So we finish off our solution by adding the numbers that minimize the sum are 1 and 1. I like this a little bit better than just saying the first number is 1 and the second number is 1. It's more meaningful and accurate. In fact, let's go back and revise our answer to the first question. Instead of just saying the two numbers are radical 185 and radical 185, let's say the numbers that minimize the sum are radical 185 and radical 185. Number 8. The sum of the first number squared and the second number is 54, and the product is a maximum. Don't forget to define your variables. Now, the first part of the sentence gives us the secondary equation. The sum of the first number squared, so that's going to be x squared plus, and the second number, so plus y, is 54, equals 54. There is your secondary equation. The last part of the sentence tells us the quantity that we need to optimize. The product is a maximum. We need to make up a variable. Let's use p for product. Of course, that will be x times y. So we need to find the absolute maximum of this. This is too many variables to be finding the derivative and such. So let's rewrite the primary equation so we can do a substitution. Subtracting x squared from both sides, we get y equals negative x squared plus 54. So let's substitute this in for y. So we get p is equal to x times negative x squared plus 54. With a little distributive property, we get p is equal to negative x to the third power plus 54x. Now we are ready to find p prime. P prime will equal, little power rule here, so we have negative 3x to the second power, and then plus 54. Now we need to find the critical values of p. So we need to find where p prime is equal to 0, where p prime is undefined. This is a polynomial, so it is defined everywhere. So forget about undefined. We just need to find where p prime is equal to 0. So if we set negative 3x squared plus 54 equal to 0, let's see, adding 54 to both sides, subtracting 54 from both sides, we get negative 3x squared is equal to negative 54. If we divide both sides by negative 3, we get x squared is equal to 18. Taking the square root of both sides, we get x is equal to, and normally I would say plus or minus radical 18, but x has to be a positive number. So I'm just going to say positive radical 18. So this is our only critical value. Once again, we have an unlimited interval and one critical value. So we are going to use a p prime sign chart to help us find the absolute maximum. However, before I do that, I think I would prefer to factor p prime. So we could say that p prime will equal negative 3 times x squared minus 18. Now let's make that sign chart. Label your sign chart with the p prime. I'm going to put 2 rows, one for each factor, and there's my one critical value. Also, the lower limit here is 0 because we are told that x has to be positive. Obviously, negative 3 is negative in every interval, so I'm going to put a minus here and here. X squared. If I put in 0 right here, I would get a negative number. So that helps me understand that any value between 0 and radical 18 is going to give me a negative value. If I plug in something here that is bigger than radical 18, that's going to leave me with a positive result. A negative times a negative is a positive, and a negative times a positive is a negative. The first derivative test tells us that p has a relative max at x equals radical 18 because p prime changes from positive to negative. To convert this to an absolute max, we need a second statement. Since x equals radical 18 is the only critical value, this relative max is also the absolute max. To finish answering the question, we need to also find the other number. Y equals negative x squared plus 54. So at x equals radical 18, y will equal negative. Radical 18 squared takes away the radical, so that just leaves negative 18 plus 54. So y equals 36. So for the final answer, we add the numbers that maximize the product are radical 18 and 36. Number 9. Find the length and width of a rectangle that has a perimeter of 80 and a maximum area. Let's let x be the length and we will let y be the width. If the perimeter is 80, that means that 2x plus 2y is equal to 80. So there's your secondary equation. We need to maximize the area. So let's make up a variable for area. How about a? The area will be the length times the width. So x times y. In order to find the critical values, we really need to rewrite this in terms of a single variable. So let's rewrite this expression with one variable by itself. Let's solve for y. Actually, first of all, let's divide everything by 2. So that will give us x plus y is equal to 40. Then if we subtract x from both sides, we get y is equal to negative x plus 40. Now we can substitute this for y right here. So a will equal x times negative x plus 40. Little distributive property, and we have negative x squared plus 40x. Now we need to find a prime. Power rule. So the 2 comes out, so negative 2x and then plus 40. I think we should factor this before we find the critical values. So let's factor out that negative 2. So that will leave x minus 20. The critical value where a prime is equal to 0 will occur when x is equal to 20. A prime will never be undefined, so we don't need to worry about that. Are we going to use a candidates test, or are we going to use a sign chart? This is actually a rare problem where we could do either. Since we only have one critical value and they didn't put a restriction on the interval, we could use a sign chart like we have for the other problems. However, there is an implied limit to this interval. X has to be bigger than 0 because we were told that it has to be positive. And because the sum of the two numbers has to add up to 40, any single number cannot be bigger than 40. So in other words, x has to be somewhere between 0 and 40. So we could do a candidates test using 0 and 40 as the limits of the interval. Since I did all of the other problems with a sign chart, I'm going to do the candidates test this time. For the candidates test, go ahead and label it as a candidates test, and really it's just an old school t-chart. So on the left side we're going to have x values, these are the candidates. On the right hand side we're going to have the expression that we are trying to maximize or minimize, in this case the area. So notice that we're not doing a prime, it is just a. So the candidates that go on the left side are, we start with the limits of the interval. In this case, 0 and 40. And then in between, we put any critical values that we found. In this case, the one critical value was 20. Now we evaluate the area at each of these candidates. We can do the first one in our heads. If you substitute in 0 for these x's, of course, you're just going to get 0 for the area, which makes sense. If we plug in 20, then we're going to have negative 20 squared. Okay, maybe let me just make it clear that we're going to square this first and then apply the negative sign. And then plus 40 times 20. That's negative 400 plus 800, which is 400. Now let's do the 40. So if we plug in 40, that's going to be negative 40 squared plus 40 times 40. But these are just opposites. We have negative 40 squared and this is positive 40 squared. So of course that's going to give us 0. So we have a maximum value of 400 when x is equal to 20. We say a has an absolute max of 400 at x equals 20. See candidates test. So far we have found x, the length, and we still need to find y, the width. At x equals 20, y is equal to negative 20 plus 40. So of course y is equal to 20. So add this to your final answer. The length and width that maximize the area are 20 meters and 20 meters. Number 10. Find the length and width of a rectangle that has perimeter of p meters and a maximum area. So this is the same as the previous problem, just a little bit more abstract. The last time they told us that the perimeter was 80, so we put an 80 right here. This time they're saying that the perimeter is p. So we are going to just treat p as a constant and put it right here. So far we have this. We are trying to maximize area, which equals x times y. But we need to rewrite this in terms of a single variable. So again, let's get y by itself. Dividing both sides by 2, we get x plus y is equal to p over 2. Subtracting x from both sides gives us y equals negative x plus p over 2. Let's substitute this in for y. So now we have this. This looks like we have more than one variable because we have x and p. However, p is not a variable. Treat this as a constant. Anyway, if we distribute, we get a is equal to negative x squared plus p over 2 x. Let's find a prime, just like we did last time. So a prime is going to equal negative 2x plus the constant p over 2. Let's find a critical value by setting a prime equal to 0. So we have negative 2x plus the constant p over 2 is equal to 0. Subtracting p over 2 from both sides, we get negative 2x is equal to negative p over 2. And dividing both sides by negative 2 gives us x equals positive p over 4. This is our only critical value. I think this time I'm going to do a sign chart instead of the candidates test, just mixing it up. So here's my a prime sign chart with my only factor and my one critical value. If I pick a value for x between 0 and p over 4, I'm going to get a positive number. To see that, if you go to the extreme and put in 0 right here, it leaves you with a positive p over 2. If we let x be something bigger than p over 4, then we're going to get a negative value here. For example, okay, bigger than p over 4 would be p. So that would make negative 2p plus 1/2 p. Obviously, this term is more negative than this is positive. The negatives win. The first derivative test tells us that a has a relative max at x equals p over 4 because a prime changes from positive to negative at p over 4. To convert this to absolute max, we need the second statement. Since x equals p over 4 is the only critical value, this relative max is also the absolute max. So far we have found the value of the length. Now we need to find the width y. So here is our expression for y. At x equals p over 4, this becomes y equals negative p over 4 plus p over 2. I need like denominators, so I'm going to go ahead and multiply by 2 over 2. So I'm going to write this as 2p over 4. Negative 1p plus 2p is p. So y is p over 4. Just add this on for your final answer. The length and width that maximize the area are p over 4 meters and p over 4 meters. Okay, last one. Find the length and width of a rectangle that has an area of 32 square feet and a minimum perimeter. Again, let's let x equal length and y equal width. If the area is going to be 32, that means x times y is equal to 32. So there's your secondary equation. We are trying to minimize the perimeter. The perimeter is equal to 2x plus 2y. So we need to minimize this. But first we need to rewrite this with only one variable. So let's go back to the secondary equation and get y by itself by dividing both sides by x, which gives us 32 over x. Let's plug this in for y. So we have p is equal to 2x plus 2 times 32 over x. That means p is equal to 2x plus 64 x to the negative 1 power. So let's find p prime. P prime will equal 2, and then with the power rule we get negative 64 x to the negative 2 power. That means p prime is equal to 2 minus 64 over x squared. Our lives will be a little bit easier if we make this into one fraction. We can accomplish that by multiplying the 2 by x squared over x squared. That gives us like denominators, so p prime will equal 2x squared minus 64 over x squared. Let's go ahead and factor out that 2. So p prime will equal 2 times x squared minus 32 over x squared. Now we need to find the critical values where p prime is equal to 0 and where p prime is undefined. Where does p prime equal 0? Well, a fraction will equal 0 when the numerator is equal to 0. So that means 2 times x squared minus 32 must equal 0. Dividing both sides by 2 gives us x squared minus 32 is equal to 0. Adding 32 to both sides gives us x squared is equal to 32. Taking the square root of both sides would normally give us x is equal to plus or minus the square root of 32, but we were told in the setup that these numbers have to be positive. So positive radical 32. This is the only critical value because the other critical value would come from p prime being undefined, which would mean that the denominator would have to equal 0. But if you take an already positive number and square it, you will get a positive number, not 0. So forget about that. Because we have an unlimited interval and one critical value, we can find the absolute minimum using a sign chart. So here's your p prime sign chart with a row for every factor in the p prime and with the critical value at the top and the lower limit of 0 because x has to be bigger than 0. 2 is going to be positive in every interval because it's just a positive number. Similarly, x squared will be positive in every interval because if you take a positive number and square it, still positive. On the other hand, if you pick a number between 0 and radical 32 and plug it in right here, you're going to get a negative value. It's easy to see if you go to an extreme and put in 0 right here, that's negative 32. If you put in a value bigger than radical 32, for example, if you put 32 squared minus 32, that's positive. With a single negative in this column, we're going to get an overall negative value for p prime. With all positives, we're going to get an overall positive for the p prime. The first derivative test tells us that p has a relative min at x equals radical 32 because p prime changes from negative to positive. To convert from relative min to absolute min, we need the second statement. Since x equals radical 32 is the only critical value, this relative min is also the absolute min. So far we found the length x, but we still need to find the width y. At x equals radical 32, y will equal 32 over radical 32. We could leave the expression like this, but it does simplify down quite nicely if we rationalize the denominator. So let's multiply by radical 32 over radical 32. This will give us y equals 32 radical 32 divided by 32. The 32's cancel, and we have y equals radical 32. Where have I seen that before? Analyze your answer by adding this. the length and width that minimize the perimeter are radical 32 feet and radical 32 feet.